The next topic in musculoskeletal ultrasound principles is artifacts. We're going to talk about these, which are the main sound artifacts, and we'll divide them into two small sections. Understanding that artifacts are images that aren't real. They're images produced by physical phenomena and can either help or hinder diagnosis. That's why we need to know them perfectly. So the first artifact is the acoustic shadow, and this is typical of bones. When we have our anatomical segment, like this knee, we can identify the bones because they have a hyperechoic image that corresponds to the cortex. A lot of density, high speed of sound, a lot of reflection. This results in hyperechogenicity with a posterior acoustic shadow, which is typical of bones and calcifications. Let's look at it in the example then. On the ultrasound, this would be the hyperechoic image of the cortex. The sound is completely reflected, and what lies beneath, which corresponds to the posterior acoustic shadow, allows us to identify our patella. Let's look at another example. This is a rotator cuff, where on the right we see a normal rotator cuff with a head, humeral and an insertion footprint with a tendinous pattern, which we'll talk about what's normal later. But here, in this example, we see the same tendon, but with an image inside it that doesn't let us see the cortex. Notice that the cortex, unlike on the right side, here is lost and becomes discontinuous because the sound reaches the calcification, which is intratendinous, and doesn't pass through due to its acoustic shadow. Posterior, the sound doesn't pass through it. A posterior acoustic shadow is produced, and this is typical of calcifications. It might look like the cortex is broken, but basically what we need to focus on here is this image, which would correspond to this segment. Let's look at it dynamically in a video. The same calcification, much larger, breaks the cortex because the sound doesn't pass through. So here you can see it, and then we don't see it anymore because the sound is completely reflected, creating a posterior acoustic shadow typical of calcifications in bones. The second artifact is anisotropy. And let's look at this position, which I'm exaggerating here to show you that anisotropy is a property found in very fibrous tissues, like tendons, where they can appear hyperechoic, anechoic, or hypoechoic in the image, depending on the position in which I place the probe or the angle, as we explained in the fundamental principles, and we'll look at it in more detail. Does that mean that if I have a tendon and I place my probe in these three positions, basically the image I will receive, the one I will see on my ultrasound, depends on how these ultrasounds are reflected perpendicularly. So in this case, we'll get this image because it's very perpendicular. I'm going to have a hyperechoic image because it receives all the sound, whereas when the probe is angled, some of the sound will be lost. Here in red then, the sound is lost, and it gives us an anechoic or hypoechoic image. This is typical of tissues that are rich in fibers, like tendons. This is a hyperechoic image. You can actually see the tendon itself. Anechoic. This sign is described as, now you can see me, now you don't. When you go to study, that's how it's described. We see it again here. This is the same tendon, and we can evaluate it. Anechoic or hyperechoic. Depending on how I position my probe here in a finger tendon, we see the now you can see me, now you don't sign, which is either hyperechogenicity or anechogenicity. It is seen in the transverse view. Anisotropy can also be seen in the longitudinal view, but it is much more significant in the transverse view than in the longitudinal. The next artifact is the critical angle shadow. What is this? The way the probe is positioned means that if I am perpendicular, it reflects, and I'll get a very hyperechogenic image. This ultrasound, which is, let's say, at the edges of the probe and travels toward the edge of a usually rounded tendon, will continue and produce this anechoic contour image that is called critical angle shadow. Let's take a look. This is our hyperechogenic tendon, because we are very perpendicular, and the contour that forms is this one, a halo that corresponds to the critical angle shadow. And you have to keep it in mind because it can be mistaken for pathology. There are some diagnostic criteria that we'll see in the respective chapter where it's discussed when this is pathological or not. But basically, the way to understand it is that by moving the probe, I can determine whether it's a critical angle shadow or if it's pathology.